Okay, so recently we have probably not seen too much info about SpaceX's Starship HLS lunar lander, but that doesn't mean SpaceX and NASA aren't focused on developing this. More than we think, these two organizations are intensifying design changes and conducting crucial tests to create the newest and most unique lunar lander variant ever. Let's find out more on today's episode of Alpha Tech, and thanks for checking us out. And before we get into today's content, we just want to let you know, first, thanks for checking out this video. We are very close to hitting 100,000 subscribers, so if you enjoy space news and analysis like this, please press that subscribe button, and that way you'll never miss out on any of our daily videos. Now, let's get into today's news. Okay, so it's understandable why new variants take time to develop, as they are constantly evolving to change the most optimal and efficient design for a successful journey to the lunar surface. Since SpaceX won the HLS contract in 2021, NASA and SpaceX have revealed some renderings of the exterior of Starship's HLS. At that time, the vehicle looked quite similar to a standard Starship, although the aerodynamic control surfaces and heat shields were removed. The crew would access the lunar surface via an elevator, and power would then be supplied by a small ring of solar panels around the nose of the lander. Since then, the design of Starship HLS has changed a lot. NASA and SpaceX have optimized their lander to overcome the unique challenges posed by lunar exploration. On November 2nd last year, two drawings believed to be of the new design for the Starship human landing system got leaked by David Willis on X. The accuracy of these drawings could not be confirmed, but to be honest, they appear pretty similar to previous official descriptions that SpaceX gave of the vehicle. To start with, this design of the Starship lander is taller than previous versions, comparing the scale between old and new renderings. But how accurate this is remains to be seen. As early as December 2021, SpaceX CEO Elon Musk hinted that this company might increase the size of Starship's fuel tanks. And now SpaceX is starting with larger Starship version 2 prototypes. So there's no reason that Starship HLS could not be taller as well. By extending the fuel tanks of the Starship, SpaceX will be able to load more fuel onto the lander. This decision could be an effort to enhance the performance of the Starship for lunar missions, which requires more delta-V, change in velocity, than flights to low Earth orbit. Additionally, the HLS Starship must remain in lunar orbit for up to 100 days while waiting for the crew to get there. Larger fuel tanks will allow it to carry enough liquid methane and liquid oxygen for landing, even accounting for fuel loss due to evaporation in space. SpaceX has also adjusted the paint scheme of the lander. In every rendering released so far, HLS has been painted white. This coating is not just for aesthetics. White surfaces reflect nearly 100% of the incident solar radiation, helping to reduce the rate of fuel boil-off. While this remains true for most of the vehicle, the new renderings reveal that its engine section is painted black. The reason for this might be that black surfaces absorb most of the incident solar radiation, which could help keep the 6 Raptor engines of the Starship warm in the moon's cold shadows. Aside from minor changes in deployment angle and spacing, the 4 landing legs of the Starship don't seem to have changed much. However, they are no longer housed inside enclosed aerodynamic fairings. Instead, they're simply retracted and pressed tightly against the body of the lander during launch. This decision indicates that the landing legs are strong enough to withstand the high winds blowing past the rocket at hundreds of miles an hour as it ascends through the atmosphere. Additionally, it implies that Starship's Super Heavy booster will generate enough thrust to counteract the drag from these 4 protrusions. The most noticeable additions to the Starship lunar lander in this rendering are its 5 large solar arrays. These arrays will serve as the primary power source for the lander in space and on the lunar surface. During launch, each solar array is stowed in a rectangular compartment beneath the crew cabin. Depending on the design that SpaceX has chosen to use, they will then unfold or roll out to a deployed length of about 60 feet. The solar arrays are spaced 30 degrees apart in a hexagonal pattern. One panel is omitted so that the commander and pilot of Starship can get a clear view of the moon's surface during landing and to deploy the elevator for the moonwalkers. While the HLS is orbiting the Earth or Moon, the solar arrays will be oriented perpendicular to its fuel tanks. The spacecraft will point its nose toward the sun so that all 5 arrays can generate power. It wouldn't be surprising if they got retracted during landing to avoid damage from vibrations or debris kicked up by the engines, although this hasn't been confirmed by the renderings. When the Starship's on the moon's surface, the arrays will be positioned along the lander's body. At the moon's south pole, the sun's always close to the horizon. Therefore, this vertical orientation will maximize the amount of energy the lander can collect on the moon. Notably, these solar arrays may have a larger collective surface area compared to the small cylindrical array introduced in previous renderings. Therefore, the energy requirements of the lander could have increased. The increased power budget could be used to power the 450 kilos of equipment that Artemis 3 is going to carry, to run cryocoolers that can extend the storage time of the liquid oxygen and liquid methane, or for completely different purposes. The new renderings also confirm that Starship HLS will be equipped with small landing thrusters beneath the crew cabin. Most of the powered descent of Artemis 3 will be handled by Raptor's engines. However, these 6 powerful engines are likely to cause significant interactions between the plume and the surface during landing, kicking up large amounts of rock and dust beneath the lander. Instead, Starship will gently be lowered to the moon's surface by these small elevated thrusters. And more recently, in a NASA article from April, the agency showed us another rendering. Checking out this design, we immediately see differences between the new lander and the previous one. The large solar panels are no longer there. Instead, there's a smaller black ring below the hatch. There are no longer any cabin windows for the crew, reminding us that both vehicles will be fully automated. The most striking feature is the new cargo crane, much larger, taking up most of the open body of the ship to support a massive crane. This crane is unloading what appears to be the initial design of a pressurized rover. This type of vehicle is being deployed by the Japanese Aerospace Exploration Agency, JAXA, and Toyota for NASA. And it's not just the new renderings that show the development of preparations for Artemis next year. It's also reflected in the successful milestones previously achieved by SpaceX in cooperation with NASA. SpaceX has completed what the company calls a propellant transfer demonstration, something that's never before been done in a microgravity environment. According to a December email from NASA explaining the test, the goal was to transfer 10 tons of liquid oxygen on the Starship vehicle from one tank to another. This is a stepping stone for Starship refueling to be able to perform in-space refueling capabilities for spacecraft, especially crucial for the mission of Starship's HLS. To undertake the 1.4 million mile journey to the moon, Starship is going to need to fully load those tanks. Although a SpaceX rep stated that they'd need to review flight data to determine their success in fuel transport, just by completing this mission, SpaceX will have gained tons of new insights regardless of how things go, and that'll enable them to upgrade their prototypes. Of course, we all want the most positive outcome, and that's success. Furthermore, in March of this year, SpaceX and NASA successfully did a 10-day trial of the new Starship HLS assembly system. They executed over 200 different assembly scenarios at various speeds and angles. The results from this comprehensive testing will be integrated into the existing computer models of the system, which will then inform future testing and design. During this round of tests, NASA and SpaceX demonstrated the soft capture procedure. In passive capture, the chaser extends its soft capture system, SCS, while the target spacecraft system stays retracted. The chaser does all the work. It employs latches and other mechanisms that grab the target spacecraft and then complete the docking. HLS requirements state that there must be redundancy in crew egress-ingress. The soft capture procedure seems to address this if the docking system works while the docking system stays retracted. In addition to these achievements, SpaceX has also done astronaut testing for the elevator of Starship's HLS. The elevator will transport the equipment and crew between the living area of the Starship, located near the top of the lander, and the moon's surface as they step outside for those moonwalks. The testing allowed astronauts to interact with the elevator system's flight-like design, serving both as a demo of the hardware functionality and giving valuable feedback from the crew's point of view. Constructed at SpaceX facility in California, the elevator model features a full-size basket with operational mechanical clusters and crew interfaces for testing. During the demo, NASA astronauts wore spacesuits simulating the size and mobility constraints that the crew will face on the moon. The test gave feedback on elevator controls such as gate locks, deployment interface for accessing and exiting the elevator basket, available for space cargo, and activities during basket movement along the vertical rail system. Besides the elevator testing, we cannot overlook an important experiment with the engines of the lunar variant of Starship. In August 2023, SpaceX demoed the optimized vacuum performance of the Raptor engine through a successful test, confirming that the engine could start in extremely cold conditions due to prolonged exposure in space. One challenge that distinguishes Artemis missions from missions in LEO is that the lunar lander can sit in space without firing for an extended period, causing the hardware temperature to drop lower than it would experience in shorter low Earth orbit missions. This mission brought success to Starship for such a complex component as the Raptor engine. If these tests alone may have left you somewhat skeptical about the stable development of Starship's HLS, in reality, SpaceX has surprised us already by having an integrated HLS model with life support systems. Since August of last year, a notable development has occurred: the emergence of specially designed white cone-shaped noses that experts think represent the cabin model from the HLS Starship variant reserved for meticulous testing. What sets them apart from others is that they include rectangular doors along with intricate systems of wire tubing and complex control panels. This clearly demonstrates life support components, indicating rapid progress in critical testing protocols. Simultaneously, the company is navigating a phase of transformative design modifications for this monumental lunar lander, aiming to forge an optimal and finely tuned product tailored precisely to the mission's demands. The history of space exploration has spanned many decades. Numerous spacecraft have ventured into space, marking significant milestones for humanity. Among the most notable are the missions that landed astronauts on the moon between 1969 and 1972 aboard the Apollo crew capsule. But if given the chance, would you dare to sit on those spacecraft? Before you make up your mind, let's take a look inside the legendary Apollo. Inside these spacecraft, we typically find a cramped cabin with a few closely arranged seats, a control panel, and some computer screens for working. The Apollo Command Module has a diameter of 3.9 meters and a height of 3.47 meters. It weighed 5,800 kilograms dry and had a crew cabin volume of just a little over 6 cubic meters. It could accommodate 3 astronauts for about a week. During the trip from Earth to the Moon, they usually slept under their seats. Behind their seats were storage compartments for various experiments. Imagine being confined to such a small space for 3 days, especially when gravity takes care of most tasks. Occasionally, you'd have to fasten your seatbelt for adjustment, which took around 3 to 4 seconds. That sounds uncomfortable, right? Remember that scene in Star Wars when they're rescuing the princess from the Death Star and she sees the Millennium Falcon and says, "You came here in that? You're braver than I thought." Well, that's how I felt when I saw an Apollo capsule. However, with the current advancements in the space industry, things are gradually improving. As you can see, SpaceX's Dragon is one of the most modern spacecraft with a much more comfortable crew cabin for 4 astronauts, or even up to 7. But in reality, as the entire world focuses on returning to the moon and even aiming for Mars, humanity truly needs something larger. This would be a place where we could live, work comfortably, and perform other activities like living in our own homes. The most promising candidate for this is SpaceX's Starship. If astronauts were arranged according to Apollo standards, 400 people could fit within Starship's 1,000 cubic meters. With 3 times the space allotted per astronaut, Starship would still have room for 150 people. It's truly a future home in space, comparable to the International Space Station. So, let's open the door, step inside, and discover it. With the size of Starship over 50 meters long for both Starship V1 and V2 and a diameter of 9 meters, it provides ample space for functional areas. The lower section is dedicated to the rocket's essential components, including up to 9 Raptor engines. Above this section, the spacecraft contains large fuel tanks covered by a common dome. The cargo and crew sections are located in the upper part, estimated to be over 17 meters long. The design is logically divided into 6 vertical floors, with ceiling heights varying depending on the function of each space. With about 2.5 meters from floor to ceiling, the interior is designed for comfort without hindering movement. The center of the gravity remains low, which is vital for the first successful vertical landing on any planet. First, start with the lowest floor. Here, we'll see scientific instruments, robots, rovers, and other cargo blocks. These will be extremely important for research missions. In addition, we will also see an electrical system which will provide energy to the entire system above. Therefore, this floor can be considered a warehouse in this house. Next, the second floor will be where the most important resources are stored: food and water. Besides that, you can also see a space that no spacecraft has ever had before: a garden. Astronauts can grow and care for vegetables here, creating a green space inside the spacecraft. That can be considered a way for them to relax. However, its main role is to provide an additional source of nutrition for astronauts. After eating, we'll need a space to exercise and maintain health. The third floor will have exercise machines like treadmills, weight machines, and more for astronauts to maintain physical health like muscles, bones, and cardiovascular health. Besides this floor, we'll also have bathrooms and toilets for astronauts to conduct their personal lives. There is a big challenge here. Water does not flow like it does on Earth due to the lack of gravity. So SpaceX will prepare special equipment like space toilets, wet towels, and dry shampoo to help us live more conveniently in this environment. The next floor of this house will be where astronauts have their private space, the bedroom. It will be divided into small rooms with a bed inside. Each crew member may have their own sleeping pod, similar to the capsule hotels in Japan. The room size will be large and comfortable enough for astronauts to get a good night's sleep after a hard-working day. Next, we will go to the fifth floor, the relaxation area. This floor is quite special compared to other floors. SpaceX will design large glass windows where astronauts see outer space. It will create a feeling of excitement for most of us because all this scenery that we could only see through TV or on our smartphones is now just a piece of glass away from us. Moreover, we'll also experience the feeling of floating in a zero-gravity environment on this floor. However, this is only a possibility, as with the latest renders of the lunar Starship, we do not see any large windows. This demonstrates that the design will continue to be updated in alignment with ongoing space exploration research programs. The elevator will now stop on the sixth floor, the highest of the house. This floor will be smaller than others because it's located at the top where the nose cone structure will taper. This will be the space for control systems, seats, and the main workplace of astronauts. The facilities are excellent, but space is truly harsh, and the journeys will undoubtedly come with obstacles. For a trip to the moon, the Starship trip takes 3 days, which isn't too long. However, for longer journeys, such as Mars, even a home-like environment may still face many challenges. One of the major challenges that the crew will have to face with is the increasing delay in communication with planet Earth. While astronauts aboard the ISS enjoy nearly real-time communication due to how close they are to us, the situation changes drastically as the Starship ventures farther into space. By the time the Starship gets halfway to Mars, the delay for a single message to go between the spacecraft and Earth will be about 10 minutes each way, making real-time conversations impossible. This communication lag introduces significant psychological challenges for the crew. In an era where we're accustomed to instant connectivity, the isolation of space travel can be profound. The crew will no longer have the comfort of immediate responses or the ability to interact with loved ones in mission control in real time. As they move deeper into space, the crew may start to feel increasingly cut off from Earth, which could lead to feelings of loneliness and detachment. Managing the mental well-being of the crew will be critical. Extended isolation combined with a lack of direct communication can take a toll on morale. Without the ability to truly receive emotional support or guidance from Earth, the crew will need to rely heavily on one another for companionship and teamwork. Therefore, psychological support systems, virtual entertainment, and communication strategies will certainly be carefully planned by SpaceX to minimize the impact of isolation and ensure that the crew remains mentally resilient throughout their months-long journey through space. Besides life happening inside the Starship, we also raise the question of how Starship will generate enough energy for humans to use. The journey to and around the moon could take up to 10 days, and going to Mars could take several months, presenting a complex challenge that requires a reliable and sustainable power source capable of maintaining life support systems, communications, and other critical functions. Three main power options are being considered: solar panels, batteries, and hydrogen fuel cells, each with its own advantages and limitations. Solar panels are the most familiar power source in space, successfully powering the ISS with their large solar arrays. However, scaling this technology for Starship is not without its difficulties. The ISS's solar wings are enormous, over 100 feet long, making it impractical to equip Starship with similar sized panels. Additionally, as the Starship travels farther from the Sun, solar energy becomes less efficient, meaning the panels would need to be even larger to generate the necessary power. This decrease in energy output as distance increases poses a significant challenge, especially when approaching Mars, where sunlight is less intense than near the Earth. Next are batteries, specifically those made by Tesla, which offer another potential solution. Tesla Powerwalls, designed to store large amounts of energy, could be used to power the spacecraft. These batteries are highly efficient and capable of providing consistent power for extended periods. However, they come with a major drawback, and that is weight. Each Powerwall unit weighs around 250 pounds, and carrying enough batteries to power Starship for 6 months would significantly reduce cargo capacity. This trade-off between energy storage and usable payload space is a critical factor in deciding how many batteries can realistically be brought along. Finally, hydrogen cells are another promising option. These cells generate electricity by converting hydrogen gas into water, providing a dual benefit. Not only do they produce power, but they also create water as a byproduct, which can be vital for crew survival. Hydrogen is the lightest element, making fuel cells a lighter option compared to batteries. While hydrogen fuel cells have already been successfully used to power vehicles, scaling them up to meet the demands of a spacecraft like Starship requires more development. Though promising, this technology is not yet a definitive solution, and further research will be needed to determine its feasibility for long-duration space missions. Each of these power sources has its strengths and weaknesses, and a combination of all three may ultimately be needed to ensure the Starship has a dependable energy supply for its mission to Mars. There are ways to harvest energy from external sources, but above all, we must not overlook Starship's main fuel. It is also crucial for long journeys, especially trips to Mars. With its current design, Starship will have enough fuel tanks to hold 1,200 tons of fuel. In the future, if SpaceX continues to increase the size of Starship, the fuel payload increases further, helping provide more energy for longer future missions. In particular, Starship is using liquid oxygen and liquid methane for fuel. When we get to planets like Mars, which is considered to have frozen water underground and an atmosphere rich in carbon dioxide, we can use chemical reactions to convert them into liquid oxygen and liquid methane to replenish Starship's fuel. If we can do that, we don't need to worry about fuel when exploring Mars and beyond. However, it will take time for SpaceX to develop the technology that can collect and convert those available resources into usable fuel. Everything seemed ready to go. After creating such a spacecraft, SpaceX's next task will be to press the copy button to create hundreds, if not thousands, of Starship versions for the mission of conquering the universe. With talented people like Elon and his SpaceX engineers, this scenario is certainly possible. What they need now is time. They've been making strong developments and a promising future for Starship for over the years. We will not be able to predict specifically what the future will be like, but right now we have to admit that SpaceX is changing the space race. They'll redefine the concept of space exploration by creating something that has never existed before: a house inside a spacecraft. This will blow the minds of even agencies that have created many glorious feats in the past, like NASA. More than ever, let's put our trust in Elon and SpaceX. In the future, perhaps many of us will become lucky passengers to sit on starships to go to new worlds. When we return, we'll not only tell about where we went and what we achieved, but we'll also be able to tell them about the exciting life we experienced on this wonderful spacecraft. That's all for today's episode. Thank you for watching and see you next time.